Hello, I'm Robert Pigue,
And I'm Sahit Kavukuntla.
and let's talk about power. Specifically, let's talk about power generation. From nuclear to fossil fuels to renewables like wind and solar power, there are numerous ways to generate electricity. However, many of these ways require significant investments in money, time, and land. Additionally, power generation by solar or wind energy requires a specific set of circumstances or type of climate.
For isolated electrical networks, such as rural communities, large boats, oil rigs, and all manner of man-made devices in space, which are not constantly connected to an established power grid, these limitations can be a problem. These isolated grids represent our customers who need a solution that can reliably provide power using minimal resources and setup.
To solve this problem, we can use a proprietary electrochemical converter that has been created by Shannon Yee and his team of Georgia Tech inventors. The sodium thermal electrochemical converter, otherwise known as Na-TECC, is a two-stage solid-state system that converts heat into electricity by allowing high-pressure oxidized sodium vapor ions to expand isothermically through two ion-selective solid electrolytes. The free electrons produce power and then recombine with the cations. Once the sodium vapor condenses, a wick pumps the liquid into a high-pressure plenum to begin the cycle again. This process is highly efficient, power-dense, and cheap. Additionally, the Na-TECC is highly customizable with options for solar conversion, thermal storage, and electrochemical storage. The Na-TECC also has a 20-year cycle life and is easy to take out and replace. The simple design converts heat into electricity without needing water or additional chemical reactions. It produces no vibrations and, compared to other forms of power generation, is small and lightweight.
Because of these advantages, the Na-TECC can be used to make solar power that is more simple, more reliable, requires less heat from sunlight to generate electricity, and can come with thermal or electrochemical storage built in. In addition, the Na-TECC, when not in sunlight, can be used with another source of heat, such as waste heat or heat produced from fuel combustion. The ability to use other sources of heat uniquely appeals to our base of isolated electrical grids. Using only one system, they can combine several forms of energy storage and energy creation. Oil rigs and man-made structures in space are two customers that would heavily be interested in the ability to use waste heat. Oil rigs burn extremely flammable fluid in order to separate hydrogen sulfide gas from petroleum. This process results in huge columns of flame, which is an example of wasted energy our system could utilize. Many space applications have wasted heat, and capturing this heat allows for more efficient power generation, which allows for less downtime in rovers and smaller power systems in general.
Now, let's talk specifically about cost and viability. The chart on the left details the price of energy per kilowatt hour for different sectors in the US. The chart on the right describes different possible Na-TECC systems. As you can see, the Na-TECC rivals the cost of normal power, even for sectors with lower costs. The cheapest Na-TECC system, which includes the solar converter and a way for other fuel to be used, is a cheaper source of power than any current sector has. This means that the Na-TECC presents a profitable opportunity even for customers attached to a power grid. Additionally, for specialized uses and remote customers, the cost still remains comparable to normal prices. The customers, especially those working in space applications or remote locations, are already prepared to pay much higher prices for their power. The low cost of our system will come as a shock to them. Another metric we can use to measure the incredibly low cost of the Na-TECC system is to look at the goals set by the U.S. Office of Energy Efficiency and Renewable Energy. According to this office, the average cost of concentrated solar power per kilowatt hour was 9.1 cents in 2020. Their goal for this cost is to be 5 cents by 2030. The simplest Na-TECC is far below average at 6.5 cents, and it is also nearing the goal for 2030, demonstrating how innovative and unique this technology is.
On the left, we have a picture of a parabolic solar array. These can exist independently and can be made much smaller, especially when using the Na-TECC. This small-scale implementation will be useful for residences, both remote and not, space probes, portable generators, and cargo ships. On the right is an example of a large-scale system, which will be useful for remote communities or even space colonies.
Let's take a step back and look at what we've discussed so far. The goal of the Na-TECC is to address the problem of power generation, with a specific focus on isolated electrical grids. These remote customers need a source of power that is reliable, cost-effective, uses minimal resources, and is easy to maintain and replace. The Na-TECC is a customizable solution that meets these needs at a price comparable or less than normal power, representing a chance for high profitability and overall impact. The low cost of initial investment for small applications and the ease of use of the Na-TECC means that customers can switch from other energy production systems rapidly. The combination of these factors demonstrates how Na-TECC is a unique solution that can transform energy generation, especially for isolated electrical grids. Thanks for watching.